Cryptography is the practice of safeguarding information using encryption, decryption, and hashing techniques. It has been used to protect sensitive information. Cryptography is critical in the development of blockchain technology, which relies on it to secure data and ensure its immutability. Cryptography is fundamental to the success of blockchain technology in revolutionizing industry by creating more secure, efficient, and transparent systems.
Cryptography has been around for thousands of years, and modern cryptography began during World War II when Alan Turing and his team cracked the German Enigma machine code. Blockchain technology is relatively new and was first implemented in 2009 with the release of Bitcoin. However, the idea of a distributed ledger system dates back to the early 1990s when computer scientists Stuart Haber and W. Scott Stornetta developed a digital time-stamping method to create a secure blockchain. In summary, understanding these technologies is essential in today's digital landscape, as they provide the foundation for secure data transmission and decentralized networks.
Hashing is highly crucial in blockchain technology. Hashing creates distinct data fingerprints, making it easier to identify change. Hashing protects data integrity and prevents tampering by creating a unique and fixed size hash value for each transaction. Hashing provides unique fingerprint of transaction and blocks in blockchains, resulting in a chain of connected blocks. The next part is public key cryptography. Public key cryptography is a kind of encryption that secures data transmission between two parties by utilizing a pair of mathematically related keys, a public key and a private key. It's widely utilized in modern communication systems, including secure email, online banking, and e-commerce. The purpose of public key cryptography is to create a secure and efficient means of communicating data that is not vulnerable to unwanted interception or modification. Public key cryptography encrypts data using the recipient public key, which can only be decoded with the recipient matching private key to ensure safe data transfer. RSA, Diffie-Hellman, and elliptic curve cryptography are examples of popular public key encryption algorithms.
Digital signature are an electronic method of verifying the authenticity and integrity of a document or message. It's like a handwritten signature but in a digital format. It is essential for ensuring the security and validity of the digital documents. It is a layer of protection against fraud and unauthorized access to people who do not have access to it. The way this digital signature works is when someone wants to sign in digital document. They first create a unique electronic fingerprint of the document using a cryptographic algorithm. This fingerprint is also known as a hash. The hash is then encrypted with the signer private key, created a digital signature. The signature is attached to the document and the document is sent to the recipient. If the fingerprint is not same as before, then the person cannot access the document.
A consensus algorithm is a cryptographic protocol that has achieved an agreement among a group of participants in a network. Its goal is to let all participants use a single version of the algorithm. Next is the blockchain system. It is used to record and store information in a secure and decentralized manner by linking the data together in blocks. They are usually used in transactions that occur on the network. To explain what is decentralized network, its control is distributed among network participants, not just a central participant. This kind of network is widely used in blockchain systems to ensure the validity of new transactions. Next, we'll talk about different types of consensus algorithm. In this slide, we'll only discuss about POW, proof of work, and POS, proof of stake. In POW, miners compete to solve complex mathematical problems in order to validate transactions and add blocks to the blockchain. The first miner to solve the problem is then rewarded in newly mined cryptocurrency. In POS, stakers are chosen based on the amount of cryptocurrency they hold.
Encryption. Encryption is a process used to scramble data in a way that makes it unreadable and incomprehensible to unauthorized parties. It involves converting plain text or readable data into cheaper text, which is a scrambled version of the original data. This is done using a mathematical formula or algorithm that requires a cryptographic key. Symmetric encryption uses the same key for both encrypting and decrypting data. It is a method used to perform data into cheaper text. An algorithm will use the encryption key in order to alter the data in a predictable way so that even though the encrypted data will appear random, it can be turned back into plain text by using the decryption key.
Next, we'll focus on the formula. How does cryptography work? There are two kinds of cryptography, symmetric and asymmetric encryption. In symmetric cryptography, the same key is used for both encryption and decryption, whereas in asymmetric cryptography, different keys are used for encryption and decryption. There are two kinds of key, private key and public key. The private key is only visible to the recipient, whereas the public key is visible to the public. The diagram below shows how digital signature is created and what are the roles of sender and receiver in the process. In the first step, to create a digital signature, a cryptography hash function is used to first create a hash value. The sender will then use its private key to encrypt the hash value, creating a digital signature. For the decryption process, in the second step, is done by the receiver. The receiver will receive the signed message and use the sender's public key to decrypt the signature. Lastly, for verification, the recipient will compute the hash value and will then compare the decrypted signature and the new hash value to see if both match those that are sent by the sender. If they match, it proves that the signature is valid and the message is authentic.
Advantages. There must be a lot of advantages when people like to use it because they started to put trust on this. Some of the advantages is security and efficiency.
There are also some potential disadvantages and challenges associated with its implementation. Here are some of the key ones. There is complexity and key management.
So, to conclude all of this, cryptography is an essential part of the internal working of blockchain technology. It provides the tool needed to encrypt data, record transactions, and send cryptocurrency securely, all without a centralized authority. It ensures all the blocks get added into the chain without any limit. Hashing in cryptography allows huge amounts of transactions to be stored on the network while protecting them from hackers. Transactions are made safe, reliable, and scalable with the help of cryptography.